Today we'll program a simple reward system for our game. Reward systems are an integral part of any video game because they make the game more challenging and give the user a sense of accomplishment, which will make them play the game longer. In the real Temple Run, the game rewards the user or the player by having them collect coins and keeping track of their total running distance in the game. And so we'll program these two behaviors in our clone game. We'll start with programming the coin collecting behavior. So go to the prefabs folder and then go to the _coin_segments folder. Double click on the gold coin prefab and then select the gold coin game object from the new hierarchy. This gold coin prefab does not have any collider component. So let's add a sphere collider component to it from its inspector window and adjust its boundaries so that its radius matches that of the coin. We want to detect this collider via trigger because otherwise it would look odd when the player collides with it in the game, meaning the collision has no force. So tick the isTrigger box, then add a new tag. Let's call it coin, capital C, and make sure that this gold coin game object here is tagged with this coin tag. Now we want our gold coin prefabs to be constantly revolving in the game around the Y vertical axis. So let's return to our scene and go to the scripts folder. Let's create a new script that's going to implement the coin revolving effect on our coin prefabs. Let's attach this coin revolver script to the gold coin prefab. So double click on the gold coin prefab and then add the coin revolver script to it as a component. Let's open it in Visual Studio. Go ahead and delete the start function because we don't need it here. Now to do the coin revolving behavior in Unity using C#, you must know some advanced level mathematics. So just type the following in the update function and don't even attempt to understand the code. This.transform.rotate, open a parentheses, 0, 1, 0, semicolon. Yeah, that's it. I was just kidding. This script simply says, keep changing the Y angle of the game object to which the script is attached to, which we know is going to be the gold coin prefab. Now save the changes to this script and go back to the editor. Now if we inspect any coin type bridge segment prefab and check any of its gold coin game objects, we can see that they are all tagged as coin, have the isTrigger option ticked, and have a sphere collider component attached to them along with the coin revolver script. So the changes from the original gold coin prefab have been applied to all of its derivative instances, proving once again the power of object-oriented programming and the usefulness of prefabs as a concept in game development if you know how to use it. We did not have to make these adjustments to every single gold coin game object in all of these bridge segments manually. Instead, we just adjusted the original master instance and then the effects were propagated to the derivative instances, so to speak. Let's return. Now let's add a coin type bridge segments to the bridge prefabs array in the bridge spawner script, which is attached to the bridge manager game objects, since we are now ready to deal with this kind of segments in our game. We have 5 coin type bridge segments prefabs, so we need to expand the array size of the bridge prefabs array to 13 elements. And now let's drag each of the coin type bridge segment prefabs onto one of the new elements in the array. And of course we need to make sure that there are no repeated bridge prefabs stored in the array. And also we need to make sure that the left and right corner bridge segments prefabs are each stored in the last 2 elements of the bridge prefabs array. Moreover, we'll also keep the regular eye-shaped bridge segment prefab stored in the first element of the array, indexed as 0. Now let's go to the bridge spawner script in Visual Studio and expand the selection of our random logic so that it can select from the coin type bridge segments as well. We'll go to the create segments function, and if a straight segment type is randomly picked, then we'll randomly choose from the first 11 elements of the bridge prefabs array and assign it to the seg prefab member of the small c segment object. And let's make the same adjustments to the other 2 cases. And now the L corner segment prefab is stored in the 12th element of the bridge prefabs array as I have put it. Also, the R corner segment prefab is stored in the 11th element of the bridge prefabs array as I've put it. And let's make the same adjustments to the other 2 cases. Now let's go to the player controller script and program what should happen if the player's game object collides with a coin game object in the game. We'll go down below and call the onTriggerEnter function here because the gold coin prefab has a trigger sphere collider as we've made it. So this predefined function in Unity is what's going to allow us to detect these kinds of collisions in the game because it gets called here in the script which is attached to the player's game object every time we collide with an isTrigger game object in the game. And the information of these collisions is going to be stored in a collider variable called COL that we're going to pass as a parameter for this function. Also, there is no need to type out explicitly that it's private because by default all functions and variables are private unless otherwise stated. Now, much like in the case of the onController collider hit function, where we use tags to detect specific collisions inside it with if statements, we write an if statement here that checks if this call variable has any information on whether the player's game object has collided with another game object tagged as coin. If that happens, then we want to destroy that game object so that it appears as if the player is collecting it in the game. We then want to play the coin sound in element 7 of the sound effects array. And we also want to go up here and create an int variable, which we will call coins collected, and initialize it to 0. This variable here is going to keep track of the coins that the player has collected in the game. So let's go to the onTriggerEnter function and increment it by 1 every time the player collides with a game object tagged as coin, and then reset it to 0 if the user chooses to respawn the game in the death event function. Finally, we want to display the number of coins collected on the screen so that the user can see how many coins he or she has collected in a game session as they're collecting them. So let's go to the onGUI function and create a GUI label text here, similar to how we created a GUI button, and give it these attributes. These XY coordinates place it on the top left of the screen, and now we write our string text in the second argument of this GUI.label function. We want the user to know what is it that he's collecting, so let's display coins, space. And then we'll use the plus operator to add another string text on the same line, which is going to be the value of the coins collected variable. And it's best to convert this integer to a string by invoking its .toString method. This method basically typecasts this integer as a string text. Notice that this time we've used the plus operator to add string texts and not numbers. This is a simple application of what is known in the programming world as operator overloading, which is when you use the same operator but for different use cases. I told you that you'd be learning a lot by taking this course. Now we're ready to test our newly programmed behavior in the Unity editor. So save the changes and go back to the editor. Hit play. We can immediately see that the bridge spawner script is including the newly added coin tab bridge segments in the random spawn logic. We can also see our GUI label on the top left displaying the coin count. And if the player collides with any coin game object, then it gets immediately destroyed and the coin count gets updated in the GUI promptly. Moreover, if we respawn the player in the game, then the coin count gets reset back to 0. So it looks like everything we've programmed for the coin collecting behavior in the game checks out perfectly. Now let's work on keeping track of the distance that the player has run in the game, and then we'll display it to the user in the GUI below the coin count label. So let's go back to the player controller script in Visual Studio and do that. From your high school physics class, you know that distance is speed multiplied by the time elapsed. We already have a variable that can tell us the player speed in the game, which is the player speed variable. But how do we know the time inside the game in Unity? If you go online, you'll find a lot of unnecessarily complicated solutions because the people who made these solutions don't understand how Unity works at a fundamental level. But we do, so let's see how. We'll simply declare a float, which we will call timer, and initialize it to 0. And also, we'll declare another float, which we're gonna call distance, and initialize it to 0 as well. And while we're here, let's declare an integer called distance run, and initialize it to 0. And you'll see why we need another variable of a different type for the distance in a second. We'll now go to the player logic function and increment the timer float by time.delta time in the beginning, right after we've made sure that the player is not dead in the game and his character controller component is enabled. And since this player logic function is going to be called from inside the update function, it means that it will be called once per frame. And so we can exploit the fact that this time.delta time is the timestamp between each frame to our advantage. i.e., if we keep incrementing this timer by time.delta time in each frame, we can effectively know the time inside the game. And now we can go to this line at the end of the player logic function, right after the character controller starts moving our player in the game, and compute the player's running distance by multiplying the player speed variable with the timer variable to get the distance the player has run in that frame. And then we'll store the result of that computation in the distance run integer, because the user should see his or her running distance as a whole number and not with decimals. This means that we need to typecast the distance float as an int here in this line. Finally, we'll now go to the onGUI function and create a new text label that can display the value of the distance variable on the screen. So let's duplicate this text label in a new line and change what needs to be changed. We want to make this text label 60 pixels below this text label, so put a 70 here. And this needs to say distance. And finally, we want to display the value stored in the distance run variable to the user as a string text. Lastly, we need to reset the value of the timer variable here inside the death event function every time the user chooses to respawn the game. And there is no need to reset the distance float because it's gonna get multiplied by the timer variable. So if the timer variable is 0, then so is the distance variable. And by extension, the distance run integer. Also, one final thing. Let's adjust the increment in the player speed to 10% a second. And it's a per second increment, not per frame, because it's multiplied by this time, that delta time converter. Now let's save the changes and see our game in the editor. Let's play. And here is the player's running distance being updated as he runs. And if we die and then respawn, it gets reset back to 0. Very simple, very straightforward. Okay, now the last thing we need to do in this tutorial is save both of these scores permanently on the user's computer or phone memory, so that if they turn off the game and then turn it back on, they can still see their best scores. So let's go to the player controller script and program this functionality. We'll first create an int that we're gonna call coins collected best. That's gonna store the user's best coins collected score. And we'll also declare another int that we're gonna call distance run best, which will store the user's best running distance score. Now let's go below in the script and create a new void function that we shall call save score. This function is going to be responsible for implementing the score saving functionality in our game. If you think about it, when is the best time to save our score in the game? When the player dies, right? So let's call this function immediately after the player dies in the game, which is when he collides with a game object tagged as obstacle. You see how we make a modular and reusable code? We're thinking in terms of objects and functionality. And because we're thinking this way, we've made very few errors in our code. Okay, now let's step into the body of the save score function and write an if statement that checks if the value of the coins collected variable is greater than the value of the coins collected best variable. If that's the case, then this means that the user has achieved a new best coin collecting score in the game. So set the value of the coins collected best variable equal to the value of the coins collected to update the new best score. And now we must permanently save the value of the coins collected best variable to the user's computer or phone before we can display it to him. So type player prefs .setInt, open a pair of parentheses, a pair of quotation marks. This setInt method of the player prefs class is used to store an integer of our choosing permanently on the user's device by pairing the value of that integer with a key name that we could use later to retrieve its value. I mean the integer. So let's pair it with the key name high score, all small, capital C, comma, coins collected best, and then save the changes on the user's device disk. So type player prefs .save a pair of parentheses, semicolon. Now let's repeat the same process for the distance run score. Let's write a new if statement. If distance run is bigger than distance run best, then set distance run best equal to distance run so that we can update the user's new best running score. And now we'll store its value in the user's device memory under the key name high score big D. And then save the changes. Now let me ask you something. Why is it that I wrote two separate if statements here and not just check for this condition in an else if line? Well, because if I string these two if statements together with an else if line, then if the first condition is true, this second condition will not be checked by Unity. So by separating them, we guarantee that these two conditions will always be checked by these two if statements. Okay, the last thing we'll do in this script for this tutorial is go to the onGUI function and show the user his best scores. So let's duplicate this label in a new line and make it 30 pixels below this GUI label, and we want to update the string text to say coins space collected space best. And now we retrieve the value of the coins collected best variable not from the script but from the user's device memory by using the getInt method of the player prefs class. So type player prefs .getInt, open a pair of parentheses, a pair of quotation marks, and then put the key name that unlocks the value of the coins collected best variable, which is high score big C. You can see that it's showing us an error. This is because we need to convert it to a string. So put .toString, a pair of parentheses. And now we repeat the same process to display the distance run best value to the user. So let's duplicate this label in a new line and make it 30 pixels below this distance label. Also, change the string to say distance space run best colon, and then retrieve the value of the distance run best using its associated key. Let's save the changes to our script and see our game in the editor. Let's play. We want to run some distance and collect a few coins, then die and respawn. For some reason our best scores are not being displayed in their respective labels in the GUI. So let's exit play mode and then go back to the player control script in Visual Studio and see what the problem is. The error has to be somewhere inside the onGUI function because it's in charge of drawing the labels on the screen. Let's first add space after the colon here in this label and this label as well. Now let's see if we can figure out the cause of our problem. Oh, I see what went wrong. The drawing area on the screen that this GUI function has allocated for these two labels are too small to fit their entire string texts. So let's increase the horizontal drawing area for this label on the screen to 150 pixels. The same thing goes for the best distance run label. Let's save the changes and go back to the editor and see if the problem is fixed. Hit play. And now we can see both of our best scores in their respective labels in the GUI. Let's see what happens if we break either of our best scores. And now we've surpassed our previous best running distance score. So if we die in the game, then our best running distance score gets immediately updated in the GUI because the value of the distance run best variable has been updated inside the player controller script. Now let's break our current best coin collecting score, which is 1. And it looks like we've broken our previous best running distance score as well. So now if we die in the game, then both of our best scores will be updated in the GUI, because both the value of the coins collected best and distance run best variables have been updated in the player controller script to reflect the new scores. Now if we respawn the game and then die before achieving any new best score, then the values of our best scores in the game do not change, which is what we want, of course. Also, if we exit play mode and then hit play again, you can see from the GUI that both of our best scores are saved and not lost. So everything we've done is working like a Swiss-made hand watch. And now our tutorial has come to a close. In the next couple of tutorials, we'll see how we can make a start menu and a nice looking user graphical interface that displays these scores in a professional way. Thank you.